Today we are looking at review topic 4, differential equations. We are going to work through a couple in this video, then you'll work on some more during your review time. We're going to start with question 6, which is part of the what year? 2018 administration. It is question 6, so it is a non-calculator question, and it is a differential equation with a slope field problem. So there are two kinds of slope field problems that you might run into on this part of the exam. One is a slope field that's been completed that looks like this, and in which case you're probably going to have to sketch something on the slope field, sketching through a point. This is what we're going to do on this one. The other type of slope field question are the ones we've already studied this year when we did differential equations and slope fields. We had graphs that had not been completed, had certain dots on the graph, and you had to create a slope field. So you had to find the slope at each point. If the slope was 1 and positive, then you would do a 45-degree line right here. And if it was negative, you do a 45-degree line here. And then you found the slope at every point that it is designated on the question. Oh, excuse me. So you can't leave any dots untaken care of. We don't draw vertical lines, but we do draw horizontal lines for a slope of 0. So this is the other kind where you're going to actually complete a slope field. And the one we're doing today, you're going to use a completed slope field to answer some questions. Okay, so this is a really easy first read to do. So go ahead and do your first read right here, and then read all parts A, B, and C before we start. So pause your video and do your first read. Okay, well, there wasn't a whole lot to read here. We have this differential equation right here. So we move on to slope, part A of the differential equations where the slope field is. And it says a slope field for a given differential equation is shown below. Sketch the solution, that's a particular solution of a curve that goes through the point 0, 2, and then sketch a second solution that passes through the point 1, 0. So it's giving us 2 points, 2 curves that we're drawing, and we're going to use the slope field to do it. So hopefully that you can see, if you look down here, you can see the first point is down here, or the second point is at 1, 0, and you have the other point that's up here at 0, 2. Okay, so basically this is a graph of particular solutions through given points. And I'm looking at this first given point, and I can see that everything on that horizontal plane is a horizontal line, which means they all have a derivative of 0. So if I'm going to go through this point following my slope field, then I have a horizontal line that's been sketched across here going through that point. And so that was the first graph. So this is the first one that I did. And then the second one goes through the point 1, 0. So that's down here. So when you're graphing something like this, where it's not as easy as just that horizontal line, a few things have to be true. You must go through the point they're talking about. So my graph has to go through the point here. I have to follow the curve in the slope field. So what's going on with these lines? And it has to extend past the boundaries of the graph. And what that means is you have to go all the way out to the left and all the way out to the right. If you stop somewhere midpoint in the slope field, you would not get credit for drawing a full slope field. So we need to sketch the point of the curve that passes through 1, 0 and exits both sides of my graph. So pause your video and draw in your graph. So hopefully you got the graph there. So you're good to go. That you have to follow these lines, right? So you have to follow the lines around. You had to go through that point and you had to come out the other side, going out the graph this way and out the graph that way. Remember that if you stop short, then you won't be given credit for completely sketching. Okay, so let's look at the scoring guide and see how we did. We get 1 point. There are 2 in this section available. We get 1 point for a solution curve that goes through 0, 2. So we would get this point. And then it says we get 1 for a solution curve that goes through 1, 0. So did we meet the requirement here? The curve must go through the indicated point. We did. It must follow the given slope lines, which we did, and it must extend to the boundary of the slope field. So it must go all the way out there. And we did. So we got that point. So for section 1, so far, we've got 2 points raring to go. All right. Pause your video and do your second read on part B. So as we read through part B, we noticed that we're finding the particular solution for a differential equation, which means a y equals statement. Remember, there is no safe stopping until you solve for y. We have an initial condition at f of 1 equals 0, so that's technically the point x is 1, y is 0. We are going to write the equation of a tangent line, so we need point and a slope, and then we're going to use your equation of the tangent line to approximate 0.7. So that means we're estimating, we're going to use our squiggle brackets, and we're going to use function notation in the end because that's the way the problem is given in function notation. Okay, so we're going to start with our differential equation. So this is what I was given up here in the very beginning, all the extra at the top, that was it. And so now we are going to find the slope. So I'm going to start, the first thing I'm going to do is write the equation of a tangent line. So in order to write the equation of a tangent line, I need a point and I need a slope. I have the point, I just need the slope. So since this is already our derivative equation, dy dx, then I can just simply evaluate dy dx at the point 1, 0. So remember your notation, evaluation symbol and the note and the point. So we're going to plug in the 1 for the x's and a 0 for the y's, and we're going to calculate the slope. So pause your video, calculate the slope. So hopefully you calculated it, you got 4/3. So that's my slope. So to write the equation of my tangent line, remember it's going to be y minus the y of my point, and that's going to equal 4/3 times x minus the x of my point. So now I have the equation of a tangent line. So once I have the equation of the tangent line, then I can do the second thing I need to do right here, which is use your equation to approximate. So what are we approximating? We're approximating when x is 0.7. So go ahead and make your approximation using your equation of tangent line that we just created and tell me what the approximation is. Pause your video. All right, so we plugged in our 0.7 for x. 0.7 minus 1 gives me negative 0.3. This is a fraction, so I changed this to a fraction. Now it's negative 3/10. The 3's are going to cancel, so I'm left with negative 4/10, or that simplifies to negative 2/5. So then my approximation using the function notation we made a note of right here so we wouldn't forget, and use the symbol because we made a note of that so we wouldn't forget, then you could say f of 0.7 is approximately negative 2/5. You could have said negative 4/10, or you could have said negative 0.4. So they would probably take any of those without too much trouble. Notice here that it just asked for us to approximate. But remember, sometimes in these equation problems like this, it'll also say to approximate it and then tell if it's an over or an underestimate. So remember, if it asks that to estimate that, then we would need to take and find our second derivative of the equation to be able to determine concavity. And then once we know concavity, then we can determine if it's over or under, because remember, if it's concave up, the tangent line is on the bottom, so it would be an underestimate. And if it's concave down, the tangent line is on the top, so it would be an overestimate. Now, it did not ask us to do that in this particular problem, but it is a pretty strong possibility that they could. So I just didn't want you to forget about that. So I would say if I'm doing something like that, then I draw my quick little sketches, right? And so then the approximation in this case would be over, and the approximation in this case would be under. So you would to do or predict uh, over under, you need the second derivative, and then you would need to check for that. So this wasn't part of the problem, but it's a good point, a good time to remind ourselves of that. Okay, so let's look at the scoring rubric to see how we did. So on part 2, there are 2 points available, one for the equation of the tangent line, which we had right here, and then one for the approximation using the correct notation and symbols right there. So we have 2 points here. So that means we have 4 points of the 9 so far, which means the remaining 5 points are going to come from the part C. So go ahead and read part C, pause your video, read part C, do your second read on that, and then we'll work through that. So as we're doing part C, we can see that we're working with a particular solution, so no plus C. We see it says differential equation, which means solve for y equals. And then they did remind us in this part that there's an initial condition. They don't always do that, So do keep in mind when you're doing that first read, if you see anything about initial condition, be sure and mark it in case they're not so nice like they were in this problem and wrote it down. All right, so our derivative equation from the beginning was dy over dx, which is 1/3 x times y minus 2 squared. So how do we go about finding a particular solution? Well, we need to first find the general solution, then we need to solve for our c, and then we can find the particular solution with that c in it. Remember, the expectation for me is as soon as you have taken the derivative and gotten that equation with the plus c, then you will immediately solve for c. We will not wait till the end to solve for c. We've been practicing that all year, so let's follow through with what we've been practicing. So go ahead and pause your video and go all the way down to the particular solution. Pause now. All right, let's see how you did. So the first thing we did was separate our variables, and then we integrated both sides. We can only integrate both sides at the same time, so I can't integrate that. I needed to use my u substitution to get it in the right form. I pulled out my 1/3 constant, and so I'm integrating x dx. So then I take the antiderivative of this side, I get negative u to the negative 1. The antiderivative of this side is 1/6 x squared plus c. You've got to have the plus c. Then once we have our equation here, I need to plug back in my u. So I went ahead and moved it down and made it a positive exponent when I did that. Negative 1 over y minus 2 equals 1/6 x squared plus c. So the next thing we do is find the c. So we find the c by plugging in the initial condition into this equation, and I end up with c equals 1/3. And so if you were working on a box space like this, you would need to remember that nothing that's outside this box will count. So we don't want to write outside the margins anywhere. All right, so I brought it up here and started a new list or a new column. So I have negative 1, y minus 2 on this side. I plugged in my c right here, so I have my equation. If this is not a safe stop, because the only way to safe stop is to actually solve for y, and we have not done that yet. So what I did is put these two fractions together. So I had a fraction on each side. I multiplied both sides by negative 1. So this fraction over here is now negative. And then now that I have it looking proportional, I can just turn each side upside down to get the y out of the bottom and outside of the fraction where I can solve for it. So then I just move the 2 to the other side. And this is my particular solution. And we still, even though we're not checking to see if we need a plus or a minus, like if we had exponentials or square roots, we still can plug in our condition here and check and make sure that it makes sense. So remember that my x is 1 and my y is 0. So I'm going to say 0 equals, and then I put the 1 in here. So 1 squared is 1 plus 2 is 3. Negative 6 divided by 3 is negative 2. Negative 2 plus 2 does in fact give me that 0. So this should be a viable particular solution. Again, it has to be y equals. So let's look at our grading rubric and see how we did in these 5 points. All right, so we get 1 point for separating the variables. So that's what we did right here. We get 1 point for the antiderivatives. When they're bundled together like this, where it's 2 points, it doesn't say antiderivative 1, antiderivative 2, then you probably have to get them both right to get these points, is what I've been told. So that means when we take the antiderivative both sides, so that's going to get me my 2 points here. And then we're going to get 1 point for the constant integration and uses the initial condition. So to get the constant of integration here and using the initial condition, so I probably would get my point after this. And then I would get my final point for solving for y, which is this point down here. So 1, 2, 3, 4, 5 points available in this section. Now let's take a quick look at the notes. So the notes for this say you get 0 of 5 points if you do not separate variables. So if you didn't do this, they are finished grading this section, you get 0 points. If you don't use the constant of integration, then you would get 1 point for separating the variables. You would get the 2 points for the antiderivatives, but you would not get any of the last 2 points. So the most you could get here with no constant of integration is 3 of the 5 points. So we have those notes there. All right, so that's pretty straightforward. I think we've done quite a few of those, and we've talked about the different ways that you could look at the slope field for this one. So that wraps up this problem. Okay, so the second notes question we're going to look at tonight is from the 2019 administration. It's question 4. So once again, it is a non-calculator question, but this slope field is or this one about differential equations is a little bit different than the other because it does not contain a slope field. So we have a word problem here. We have a diagram, and we're going to use the word problem information and the diagram information to work through parts A, B, and C. So go ahead and pause your video and read through the question, part A, part B, part C for your first read. So you have oriented yourself to the problem. Then we will come back and break it apart and look at each section. So pause your video now. Okay, so we have a diameter of 2 feet, which means we have a radius of 1. So I marked my radius. We are looking at the rate of change of the height h of the water in the barrel with respect to time t. We have a differential equation that we're given in the problem. We know where h is measured in feet and t is measured in seconds. So my units are going to be feet per second. And luckily, nicely on this one, they actually gave us the equation to use. Oftentimes with the geometry formulas, we have to know those. So, that kind of helps us zero in as to what we need to do on this particular problem. All right, so moving to part A, we find the rate of change of the volume of the water of the barrel with respect to time when the height of the water is 4 feet, and then where you're going to indicate units of measure. So hopefully you zero in on the fact that we're talking about a rate here, and then we see the word when. So what did we say that we're probably going to need when we're talking about rates of change, and then we start talking about when something's happening? Hopefully that you recognize that you're probably going to need a Fuegi. So for part A, and it could be if you're talking about like increase and decrease, things like that, you might even need part of the calc house. All right, so remember Fuegi is not a requirement to get points on this FRQ. It is what we practiced in class because I find it's one of the easiest ways to set up a problem when you have so much information. So since it's not required as part of your work, I'm going to come up here to the top and I'm going to set my Fuegi up here. So I'm going to have F, I'm going to have my W, when is it happening, what's my given, and what's my equation. And so the equation is given to me right here in the problem. So I'm going to say V equals pi r squared h. And I'm going to pay attention to the fact that this is a product. So I'm going to keep this part together and this part together, and I'm going to use a product when I differentiate. Okay, so what am I trying to find? I'm trying to find where the volume is changing with respect to time. So that's going to be dV over dt. When is this happening at? In the problem, it says it's going to happen when we have a height of the water. Let's see. Oh, I kind of jumped. I jumped from the radius. Sorry, I kind of lost my train of thought. So in this particular problem, then we are going to be looking at like when is this occurring? In terms of the problem, it says right here that we have 4 feet. So the when is going to be an h of 4. And then we know it's a given right here because the radius equals 1. So let's go ahead and start doing our Fuegi. In other words, differentiating the equation. So we're going to come down here and we're going to go dV over dt. And then I have a product. So it's the second times the derivative of the first, 2 pi r dr dt, plus the first pi r squared times the derivative of the second, which is dh over dt. So as I look at my Fuegi, this is what I'm solving for. I have a height, I have a radius, I don't have a dr dt, and I don't have a dh dt. So I'm going to go back up to my problem and figure that out. So how could I go about finding a dh dt? I can use this equation because that's what the equation represents, dh dt, and I can evaluate it at 4. So the two things that I needed are right here and here. So when I went up here to do dH/dt, I used the formula because it's right there, dH/dt. I plugged in my height of 4. So square root of 4 is 2. 2 times negative 1/10 is negative 2/10, which simplifies to negative 1/4. And that is going to be a win. So that's a win situation. And then to find dr dt, well, my r is 1. So what happens when I take the derivative of both sides? Dr dt equals 0. Be really careful here, folks. A lot of times when we're given this number and we're needing to find some missing rate like that, it oftentimes is 0. And I don't want you to forget about it, because sometimes that becomes critical when you plug it into the equation, because 0 times anything is 0, and it zeroes stuff out. This is one of those things that we have run into this so far this year when we did these problems and we had the ladder sliding down the wall. The ladder doesn't change, so that has a rate of change of 0. So this is the same kind of thing. So now that we have all of our information up here in our Fuegi, we can go down here, and the next step then is to plug it all in and find out what dv dt is. So go ahead and pause your video and do that now. Okay, so plug in all of the information that we found in the last step. Simplify. Anything times 0 is 0. So here I have pi times 1 times negative 1/5. So that gives me negative pi over 5, and the units for the volume is feet cubed per second. Okay, so go ahead and let's look at the scoring rubric or guide real quick, and then we'll go on to the next part. In this part of the problem on A, we have 2 points. One is for dv dt equal to this. So dv dt equal to all of this. That's the point that we're looking at there. And then 1 point for the answer with units. So answer here with units here. If you don't have the units, you won't get the point for the answer. All right, so go ahead and do your second read on part B and pause your video, and we'll come back and check it. Okay, so we can see that we have a win again when the height is doing something, when the height of the water is 3 feet. That's our question, the rate of change of the height of water with respect to time, increasing or decreasing. So referencing to increasing and decreasing would definitely be your calc house. And we know that if we reference our calc house, we know that in order to determine if something is increasing, we would need our second derivative to be positive, or the second derivative to be negative. It's increasing. Well, technically, we're starting our function here is the first derivative. So we can kind of think about using this piece right here of our calc house. But in any case, we need to find the second derivative to know if the second derivative is positive or negative. Then we can write our conclusion with our explanation as to why it's increasing or decreasing. All right, so go ahead and pause your video, find the second derivative, and determine your statement. All right, so we started with dH over dt. We took the derivative of both sides to find the second derivative, and that simplifies to negative 1 over 20 square root of h, or you could have had h to the positive 1/2 on bottom, dH dt. We wouldn't leave our exponent negative. And then the problem with this is a second derivative equation, but we know in differential equations we can't leave the second derivative in terms of the first. So we're going to substitute in the equation from the original problem at the start. Let's see, where's my paper here? Sorry about that. This original equation right here for dH dt, because that's what we were given. So when we put that back in right here and clean it up, the square root of h is going to cancel with the square root of h. That leaves me with 20 times 10, or 200. So that's what the second derivative is. So then my conclusion would be, because the second derivative is greater than 0, it's positive, at h of 3, the rate of change of the height of dH dt is increasing when the height of the water is 3 feet. So remember to FUU your answer. What did you find, and what are the units? And what does that mean? When or where is it happening at, and what are the units? All right, so let's see how we did on this part. This part was actually, according to the scoring rubric, 3 points. So the first point is getting to the 1 over 20 square root of h. So you're entertaining the derivative and getting that. So then we would get a point for here. Then we get 1 point for finding the second derivative. And so the second derivative, I'm sorry, the first derivative, where are we at? I already got that point for that. So the DH is 1 over square root of 20. Okay, so probably in this case, when we're looking at the first derivative, it's probably making sure that we understand how to get from here to here. So you get your 1 point in here. You get 1 point for the second derivative, and then 1 point for an explanation that includes all of the necessary pieces. Okay, so then we'll move on to part C. So finding the antiderivatives where that point comes from, doing the second derivatives where that point comes from, and all the good explanation here is where that point comes from. So those were my 3 points. I don't think I actually added those up just a moment ago. All right, so we're moving up to the last part. Go ahead and pause your video and do the second read. Okay, so we have at time 0, the height is 5, so there is an initial condition for us to use, which is going to be 0, 5. We are going to use separation of variables to find an expression for h in terms of t. So we're going to be finding the antiderivatives and all that fun stuff. So go ahead, pause your video, and see if you can get down to that function expressed for h in terms of t. So that would be h of t equals in the end. Okay, pause your video. All right, so how'd you do? So we separated our variables, then we integrated both sides and got our plus c. Then we immediately found our c, and then we put the c back in the equation and solved for h of t. So when I put that back in here, then I'm going to multiply everything through by 1/2. And then to get rid of the 1/2 on the h, I'm going to square both sides. So my h of t then ends up being negative 1/20 of t plus root 5, all quantities squared. Be very careful where you put that power of 2, because if you only put it on the 5, then you would not get credit for this answer. All right, so let's go to our scoring rubric one last time. And so in this section, you can see we have a possibility of 4 points. 1 point if you separate the variables. So we got our 1 point when we separated the variables there. We got 1 point for the antiderivatives. So when we took the antiderivatives on both sides, we got a point here. And then when we use the constant of integration and the initial condition to find our C, so that would be all of this getting to, I would say, and use the initial condition. So I would say it would take getting down to there to get that 1 point. And then finally, do we have our h of t? And that would be using the function notation and getting your value. So you'd be down to here. So 1, 2, 3, 4, that's how we would accomplish the 4 points. Now there is a note on the grading and scoring rubric. So look here, 0 out of 4 points if you do not separate your variables. So if you didn't do this step, they would stop grading and you finished. And then you could get 2 of 4 points if you don't use a constant of integration. So if there's no constant of integration, no plus c, no finding c, then the most you could get was 2 points. So if you separated your variable, you could get the point for separating the variable, the point for finding the antiderivatives. You would not get any of the points past that. So that's what you'd have to do to get all the points on this particular one. So we looked at these different kinds of differential equations. We looked at one where we have practiced that one a little bit earlier in the year, where we had to calculate the slopes at all the points on the slope field and draw our lines. The one tonight we looked at what can we do? How do we sketch a particular solution when the slope field has been completed for us? And then the last one, this one was differential equation, where the problem was actually an equation. So those are the 3 different main kinds that you would more than likely to see. All right, so hopefully you'll be ready to do your classwork on these topics next class. Bye, guys.